Good morning, classmates. Good morning, Ma'am Batukan. Today, I will be your reporter. My task is all about the overview of discrete geometry. Discrete geometry is one of the branches of geometry that study combinatorial properties in constructive methods of discrete. So you are now wondering what is a discrete geometry, or you are now curious about the discrete geometry. So what is a discrete geometry all about? So I have here a picture of the geometric objects. So there are a lot of objects that you can see in the screen. Am I right? Yes. Okay, so we have here a triangle, a square, a parallelogram, a rhombus, what else? A heart, a cross, a hexagon, a pentagon, the polygons, okay, and etc. In mathematics, geometric shapes are the figures which demonstrate the shape of the objects that we can see in our everyday life. Meaning, all of these geometric objects that you can see here in the screen kay makita rin ni nato sa ato ang balay, sa gawa sa balay, or miskan asa tabo adto. Example, every night, unsa man atong makita? Diba star? We can see a star every night. So a star is one of the geometric objects. And also the moon. We all know that moon is what? Looks like a crescent shape. So crescent is one of the geometric objects again. Okay? Okay, so I know that you are now questioning yourself, nganong gi-appeal man ni Althea og discussing about sa geometric objects? Nganong na-appeal man ni silang star, sila ni crescent, nilang hexagon, ni pentagon, nga related ba kaha ni? So kabalo ko nga mao na inyuhang question sa inyuhang self. So now, we will now continue because these geometric objects are related to discrete geometry. Okay? On the other hand, in geometry, shapes are the forms of objects which have boundary lines, angles, and surfaces. Okay, so let's move on to the meaning of what is a discrete geometry. A discrete geometry is concerned with properties of finitely generated geometric objects such as polytopes and polyhedra, triangulations and polyhedral complexes, configurations of lines, and more generally, hyperplanes in Euclidean and other spaces, the theory of rigid and flexible frameworks, tilings, and backings. And also, discrete geometry is one of the branches of geometry that study combinatorial properties in constructive methods of discrete. Most questions in discrete geometry involve finite or discrete sets of basic geometric objects such as points, lines, planes, circles, spheres, polygons, and so forth. So, diba, I told you nga ang geometric objects is related sa discrete geometry. Okay? It is being said that it is closely related to combinatorial geometry, and also it is focuses on the combinatorial properties of these objects, such as how they intersect one another or how they may be arranged to cover a larger object. Okay, so let's move on. What is a polyhedra, polytopes, and tessellations? Okay, so sorry kayo, wala na ako nabutang ang word nga polytopes, kaya nalimtan ako ubutang gyud. Sorry jud kaayo, pasensya. So anyways, let's go first to the meaning of what is a polyhedra. A polyhedra or a polyhedron is a three-dimensional solid made up of polygons. So what are the polygons? So katong hexagon, pentagon, and so on and so forth. Let's continue. It has a flat faces, straight edges, and vertices. For example, a cube, a prism, or a pyramid are polyhedrons. So, basin makita ra ninyo ang picture nga naa sa luyo, mura siyang background. So, naay cube din ha, naay prism, naay pyramid. So, those are the examples of polyhedra or polyhedrons. Okay, so let's proceed to the meaning of a polytopes. A polytope is the convex hull of finitely many points in a Euclidean space. So as you can see in the picture, naay letter P din ha. So meaning, kana nga letter P is mauna siya polytope or mauna siya ginatawag nga convex hull. Okay? Okay, so let's proceed. Okay, next is, what is tessellations? Okay, so a tessellation is a special type of tiling or a pattern of a geometric shapes that fill a two-dimensional space with no gaps and no overlaps. That repeats forever in all directions. Okay. Okay, so as you can see in the picture, naay geometric shape nga gigamit jud, diba? Specific geometric shape siya that fills a two-dimensional space nga wala siya mulapaw. Meaning, with no gaps and no overlaps. Okay? So, ang gibuhat ra sa geometric shape is gabalik-balik ra siya hangtod sa hangtod, pero same ra iyahong directions nga iyahong gisundan or gisugdan. Okay? Okay, so the next slide is the different pictures about the covering, the tiling, and the packing. Okay, so asa man kugikan ani nga mga words nga covering, packing, and tiling. So, if we are going to go back to the meaning of what is a discrete geometry, it says here that the theory of rigid and flexible frameworks, tilings, and packings are discrete geometry. So, packings, coverings, and tilings are all ways of arranging uniform objects, typically the circles, the spheres, or tiles, in a regular way on a surface or a manifold. Okay, so let's move on. Okay, so these are the main topics include. Okay, so first is the basic on convex sets. Next is convex polytopes, hyperplane arrangements, polyhedral combinatorics, high-dimensional convexity, embeddings of finite metric spaces into normed spaces, combinatorial complexity of geometric configurations, intersection patterns and transversals of convex sets, and lastly is the geometric Ramsey type results. Okay, so in conclusion, discrete geometry is a mathematical discipline studying the properties of discrete geometric structures, which are arrangements of elementary geometric objects such as points, lines, planes, circles, spheres, polygons, polytopes, and etc. And it also provides methods for solving various problems defined on such structures. And also, a sphere packing is an arrangement of non-overlapping spheres within a containing space. The spheres considered are usually all of the identical size, and the space is usually three-dimensional Euclidean space. However, sphere packing problems can be generalized to consider unequal spheres, n-dimensional Euclidean space, where the problem becomes circle packing in 2 dimensions, or hypersphere packing in higher dimensions, or to non-Euclidean spaces such as hyperbolic space. A tessellation of a flat surface is the tiling of a plane using one or more geometric shapes, called tiles, with no overlaps and no gaps. In mathematics, tessellations can be generalized to higher dimensions. Thank you so much for listening, everybody. I hope that you've learned something from the discussion that we did. Okay? So again, thank you and have a great day ahead.